we'll just do this one step at a time. The argument of z, and that's z there. So I want the imaginary component of something on 2i. There we go. Clearly that's not enough room. Plus 6. So the imaginary component of this thing here is z1 times z2. So the imaginary component of that expansion, if you can't do that expansion, just go back and do some easy repetitive questions and you will come to, because it's just crab claw and combining like terms. Okay, so what's the imaginary component of that? It's going to be 4 root 3. Remember, the imaginary component is just the number in front of I. It does not include the I, so it's just 4 root 3. This is a bit of a problem because I don't want the I in the denominator, so I'm going to rationalise that times I on I. So that's going to be 4 root 3I on 2 times I squared. So that's a negative. So Z will equal 6 minus 2 root 3I. Okay. The argument is theta, which is arctan of y on x, which is root 3 on 3. That's not something that we recognise readily, but if I do a backwards simplifying, that thing there is going to be 3 on 3 root 3. Come on, pen. Which is 1 on root 3 with a negative there. Okay, so we want a triangle with a 1 and a root 3 in it. There we go. So a 1, 1 and a root 3. So that's our 1, 2 root 3. Well, that's pi on 6. And this is opposite, and that's adjacent. So there we go. So theta will be pi on 6. Apart from the fact that we've got this negative here, so I know that in my cast quadrants I want a negative slope, so it's either here or here. Well, how do I know which one it is? Let's go back to our answer, which is 6 minus 2 root 3. On an Argand diagram, that would be 6 and minus 2 root 3, because that's the x is the real axis and the y is the imaginary axis. So there's our pi on 6. So it's a negative pi on 6, which is our answer.